In my previous two videos, I already covered for the relay protection coordination for this 75 kilowatt motor with this motor protective device, the circuit breaker, and also the incoming circuit breaker, incoming low voltage circuit breaker with LSIG relays feature for this 415 volt switch gear. And today I will cover for this transformer high voltage side, which is here medium voltage 6.6 kV 6.6 kV side protective device setting and coordination. So basically we will have to set 51 and 50 IDMT overcurrent and instantaneous. So let's see what is the basis for this. For that purpose we need to assign here definitely one CT, this current transformer. I will define what will be this CT rating, what will be this high voltage transformer high voltage side CT rating. Let's check the transformer primary side current, which is 218.7 ampere. So let's select 300 ampere CT here. Let's select 300 ampere CT. That's all. Now we need to add one relay. Okay, so what is the basis to set 51 and 50 for this relay? Let's assign this CT first with this relay. So this CT5 already it is assigned here. Let's select the base. Also it will select this transform TR01. No, sorry, this is for TR07. So let's change this one. This is TR07 winding transformer. So full load current, you can see this is 218.7 amps. And go to this OCR phase overcurrent. Here as you can see this is IDMT. Okay, let's select the relay first from the standard manufacturer. Go to this library. I will select ABB. Let's select RDF 542 plus relay overcurrent. Okay, here this overcurrent, this is for 51, this is for 51 setting, and this is for 50 setting. So we'll discuss in this video, we'll cover this 51 as well as this 50 for this transformer high voltage side protection coordination purpose. Okay, so let it be up to this. Okay, so let's check what was the transformer high voltage side rating. It was 218.7 amps. So let's use one Excel file here. 218.7 amps. Let's say this is for 51 or 51. So FLC is 218.7 amps. Okay, and CT ratio is, we have selected 300 by 1. Let's select 300 amps. So what will be the pickup? So this 51 pickup setting, the formula is full load current. This is full load current into 1.1 is the factor of safety or the safety margin divided by 0.9 under voltage, and now the CT ratio. So this is the formula. What I have written is the full load current, this pickup setting equals to the full load current into 10% overload margin, the factor of safety, divided by 10% under voltage, that's why it is 0.9, and this CT ratio. So this is the formula. So now it is coming 0.891. So 0.891 we will select as 0.9. So at 0.9 the current is coming, but equals to 0.9 multiplied by this CT ratio, so 270. That means if we set the pickup this 51 pickup setting, this 51 relay pickup setting as time, this relay multiplier is 0.9, then 270 will come. So let's select from this relay. So go to the relay here, go to OCR here, let's select this one, extremely inverse. So this was 0.9, that means 270 amps. 0.9, this is 270 amps. You can see this is 0.9 corresponding to 270 amps. Okay, and this time delay, let's see 0.6. With respect to downstream, we need to coordinate this time dial. Let's say 0.6. Okay, now we have set the 51 setting. Now coming to this 50 instantaneous. For this instantaneous setting, before proceeding we need to be very clear about the procedure, how we can do this. So firstly we need to check what is the fault current here at the transformer secondary side, in case of any fault here at transformer secondary side, and correspondingly what will be the reflected fault current at high voltage side. We need to set this high voltage side 50 setting based on that. So once again I am repeating, based on the transformer secondary side fault level, the reflected fault current at transformer high voltage side, based on that we need to set the 50 setting. That means the sensitivity, the relay pickup will be set. So for that purpose we are going to run this short circuit to find out the short circuit fault current here at transformer secondary side. So let's run this one. SCMAX case study. Here the maximum condition, the C factor is for less than 1 kV it is 1.05, and for high voltage side this is 1.1. Okay, let's run this. Okay, so what is the short circuit current is coming here at secondary side. This is 34.736 kilo ampere. 34.736. So this is for 50 setting. 34.736. This is kiloamps. This is the fault current, IF fault current at secondary side. What is the reflected primary side fault current? Reflected secondary side fault current, that will be equals to this multiplied by 415.415 divided by 6.6 K. So this is the reflected fault current at transformer secondary side, which is 2.18 kiloamps. So based on this 2.18 kiloamps, we need to preliminary set this 50 setting. So what will be the pickup for this? What will be the pickup for this 50? This pickup will be equals to reflected fault current we need to consider here 30%, 1.3, 30%, including all safety margin, and I will convert it to ampere, from kiloampere to ampere, so multiplied by 1000. So now it is coming in M. So 2839 ampere. So this is the pickup current. So what will be the pickup setting? This pickup setting will be this pickup current divided by this CT ratio, which is 300 amps. So 9.46. So we will set at 10, and corresponding to 10, the current will become this multiplied by CT ratio, that means 3000 amps. Here it was 270 amps. So let's, okay, before proceeding further, so this is the setting we need to provide the input at a relay. The setting as 10, but before that, one more parameter we need to check here. We need to check what is the minimum short circuit fault current at 6.6 kV bus. Once again, at 6.6 kV bus, what will be the minimum short circuit current, so that the relay can cover that part also. Ideally, that minimum short circuit current will be more. Actually, the relay should be said, the relay pickup should be below this minimum short circuit current of this high voltage side switch gear. Once again, I am repeating, the relay pickup setting or the relay sensitivity should be opted out considering the minimum short circuit current rating of this high voltage side switchboard, so that this relay pickup setting will be lower than the minimum short circuit. So this is one of the criteria, so that during the short circuit condition for this switchboard, to sense the short circuit fault, this relay pickup should not be more than that. Let's see, for that purpose, let's check what is the minimum short circuit level at this 6.6 kV switchboard. So we are in the short circuit mode here. Let's select this SC min. Okay, so in this mode I will run. Okay, let's check what is the condition here. Minimum, I have selected minimum. For this maximum short short circuit case study I have selected maximum, and here now this is minimum. Okay, now we need to run this 60909 IC 60909. Let's see what is the minimum short circuit level here at this 616 kV switchboard. Okay, so 4.489 kiloampere. What is this actually? This is three phase. This is three phase fault, not single phase. Okay, so this is 4.489 kiloamps. 4.489 kiloamps. 4.489. So minimum SC short circuit level 4.489 kiloamps. So our relay is being set at 3000 ampere because the actual current is coming 2839 ampere, which is less than this 4489 ampere or 4.489 kiloampere. So we can set the relay at 10, that means at 3000 ampere. I hope this is clear. So let's go back to ETAP here. Now let's select set that overcurrent protection, this 50 setting. So now this is 10 we have set, and here this is 3000 ampere primary current. Okay, and instantaneous, basically this is not instantaneous, we'll cover. Suppose this is, there will be a time delay, suppose 0.4 second, it's 400 milliseconds. So this is basically short time. This is basically short time, definite time, not instantaneous basically. Okay, so because this is the incoming power supply to the transformer, so that instantaneous with time delay 0 is not suitable for this feeder. Okay, let's uncheck this neutral and ground as well, and also this overload. Let's switch off. And one more feature here, integrated curves, block TOC by IOC and combine for the combined curve will get. So this is the 51 setting and this is 50 setting. Let's check with the TCC curve what it is coming. So in the star view, this is star manager, we are appending this one, append. Okay, that's fine. So this is the curve actually. Okay, yeah, now if we zoom a little bit, if we turn on the grid here now, this, so this is the setting, this peak of 0.9, time dial 0.6, instantaneous 10, time delay 0.4 second. Okay, and also we need to run this after adding this relay circuit breaker. We need to run this clipping short circuit so that the curve will be clipped. So whenever you are adding any new element, new relay or any protective device, so you need to run this run update short circuit KA so that the curve will be clipped like this. So previously it was extending up to infinite, but now it is clipped. Now it is clipped here. So maybe we need to coordinate with this downstream circuit breaker. If you can recall, this is the downstream low voltage side, transformer low voltage side circuit breaker, which is coming to LV 415 volt switchboard in commercial circuit breaker, and this is motor protection circuit breaker, and this is motor starting curve. So we need to give the time delay here. So yeah, this should be coordinated with the downstream. Yeah. So go to devices, release, phase, SU1. Okay. Okay, fine. So these are now coordinated. So this is the coordination process. It's the motor starting curve, then motor protection circuit breaker. Now it is based in between motor starting curve and motor hot withstand curve. This is main switchboard low voltage side, switchboard incomer setting. Yeah, with release, and this is 6.6 kV side relay, ABB relay, and these are coordinated now. So we have already covered from here transformer high voltage side, this transformer low voltage side, which is in turn the incomer of this LV board, this motor protection circuit breaker along with this 75 kilowatt motor. So in these three videos, in these three parts, I have covered this section from 6.6 kV up to LV motor.